So, hi everyone, welcome back to my channel. Today we will learn an important concept of coordinate geometry. We will learn that how to represent a line when it is parallel to x-axis and y-axis. So let's go ahead with it. So here I have quadrant, the very basic thing. Four quadrants I have with the x-axis and y-axis. And now I will tell you how to write the equation of x-axis and y-axis, right? So let's go ahead with the very first concept. I will choose first to tell you that how to represent a line when it is parallel to x-axis. Let's study this one first. So here I will take line, right? I'm drawing it in blue color so that so that we know that this is the line, right? We have to find the equation of this line. So we can name this point where it intersects with the y-axis as something like point A. Let it be our point A. And we can easily see if in the diagram that it is y-axis passes through x 0, 0, which we have. So now as it is 0, 0, this point A, once again, this may not be looking clear to you guys. I'm writing it again. So let it be point A. Now this point can have a coordinate of something like 0, y1, where y1 is some constant value through which it is passing, right? Now, if I take some point here, which is B, right? Let me take one point B. It can have some value as x1, y1. Now, I would like to tell you one thing, that if you draw a line perpendicular from B, right from B, perpendicular to x-axis, right? Then it will touch the point here on x-axis at x1, 0. Again, if I take a point here as C and give it some coordinates like x2, y2, y1, we will always have this y1 in all these cases. We will always have the ordinate y1 because it's a parallel line to x-axis. So the y coordinate will remain same. That's one thing, right? And at the same time, x coordinate can change. So this you have to remember, that if a line is parallel to x-axis and if it is passing through any point A, which lies on the y-axis, then the ordinate or the y coordinate will remain same, while x coordinate can change. This you have to always remember. And again, if we draw a line perpendicular from C to x-axis, it will uh, intersect the x-axis at x2, 0. So you can easily see that here C is a point. It is going through a line. For the line which passes through y1, the y coordinate will be y1. And if a line which is drawn perpendicular from x-axis to L, if it intersects at a point C, it will have the same coordinate. I hope this concept is clear to you. And now coming to the equation of our line, which is L. We are considering L to find out the equation here. So we can easily observe that for that points A, B, and C lie on L, as we did. Now, these 3 points have one thing in common, and the one thing that is common is that they have same y coordinate or ordinate, right? They have the same y coordinate. So we can simply say that if any equation satisfies something like y is equal to y1 can be the equation of this line L, because it has nothing to do with how the x coordinate is changing. The equation should be completely independent of the x coordinate. So this is our line. This is our equation of line. So let us say if you get in exams like something like this, if you are getting these two lines, let me draw it with a different color. If you get something like this one, and if you get something again like this, right? So what happens is that now if I name it something as point, let it be something like this, point A1, and A1 has some coordinate as 0, 8, and this one as A2, 0, -6. Let it be something like this. So we can say that, and let this line be L1, this line be L2. So equation of line L1 will be y is equal to 8, right? This is our answer here. And if someone asks me about this line L2, right? Here we have L2. So equation of L2 is equal to y is equal to -6, because it is always going to remain same for this line throughout, and hence which implies that y plus 6 is equal to 0. So this is the equation of line L2. I hope this concept is clear to you guys till here. Now we will move to the concept of how to represent a line which is parallel to y-axis. So let me remove this first. Yeah, it went now. So so let me draw the 4 quadrants again. So now what we have here is that we have this as origin, which is 0, 0, as we all know. This one is our x-axis, again, as I have told you in the previous example, right? So now we need to understand that concept of any line which is parallel to the y-axis. So let me draw this line as the first example to show you the concept of it. Okay, then now this line I am naming it as L, and let me name this point as A1 again. Let me name it as just A, and we can see that this might be some point on x-axis, so we can simply name it something like x1, 0. Now if you move ahead somewhere in this line, let it be a point B, we can say this line as we can have this point as something like, one second, let me write it here. We can have this line's point something at B is equal to x, y1. Now I can confidently say this because since it is a line vertical to y-axis, the x coordinate will always remain same. In case of a line parallel to x-axis, we had the y coordinate same. Now we will have the x coordinate always same. And if you draw a line perpendicular to y-axis from B, you will have its coordinate as 0, y1. And if you take another point C again, something like x1, y2, and draw a line perpendicular to y-axis, it will something like 0 comma y2. Now again in this situation, you can easily see that no matter wherever we take the point on this line L, what happens? X coordinate remains same, right? And y coordinate changes. This is exactly opposite to what we saw in case of the line parallel to x-axis. And similarly, we can have the equation independent of our y coordinate. So the equation will be equal to x is equal to x1. This is our equation for line L. Now let me take some example, one numerical example here. Let me draw it as something here and one here, right? So we can name it this point as something like A2 comma. Let me name it as 6 comma 0 and this point as A3, which is minus 8 comma 0, right? So, and let me name this line as L1, this line as L2. So if someone asks me the equation of L1, it implies to be x is equal to 6, because no matter wherever we go, we will have something like 6 comma C1, some constant, then we will have 6 comma C2. We will get numbers like this, right? This point can be for say 6 comma 1, 6 comma 2, it goes like this. So this is our equation of line L1. Coming to the equation of line L2. Now in L2, we can again see that this line passes through minus 8 comma 0 and and here we can have something like minus 8 comma C3 and anything like that. So no matter whatever point we take, we will always have this x coordinate as 8 or abscissa as 8. So the equation will be x is equal to minus 8. It will be independent of y, or we can write it as x plus 8 is equal to 0. So this is our equation of L2. I hope you guys understood till here. And now I would like to tell you one more thing, a few things more related to the same topic. So let me clean this mess first. Okay, so till now, one more thing. So now I would like to like you guys to ask along with the explanation. So let me draw it first. Again, we're taking these two axes, right? So this one is this is our origin, this is x-axis, this is y. So now let us say if I ask you that equation of line parallel to x-axis, right, passing through equation of line passing through 6 comma 8, right? If I ask you this question, so here you have to just focus on the y coordinate, because I told you that okay, I just 1 second.